The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
It's actually kind of a kick when the two previous speakers use products that my center has produced. Fortunately, I wasn't an author on either of them, so I don't get any credit, but it's good to see my logo up there. So thanks, guys. I appreciate the marketing. I do want to start this by acknowledging my co-authors, one of whom is Dale Harrington. He's the real guru on all things overlays. He wrote the book that Tim referred to, and many of these slides I stole from him. He gave me about 140 slides. When I pulled it down to 20, 25 of them, he still spent an hour coaching me through them. How long have I got? Okay. The other person I do want to acknowledge is Dr. Jim Cable. Now, Jim was a unique guy. He actually did his PhD pretty late in life. He was a real curmudgeon and a lot of fun to hang around with. If you were in a room of professors, deans, university presidents, he was Dr. Cable. The rest of us, George, Fred, Mike, Harold, his health has not been good, and the reason I'm talking about him here is that he was intimately involved in this project. He retired from the civil engineering department about 2 years ago, and about 3 weeks later, his wife phoned Dale and said, "Get him out of here." So we banished him to northern Iowa for 4 months, and he did this project. And in fact, I got an email from him this week saying, it was actually one that's very precious to him. When I was putting these slides together about a month ago, he had informed us that he had 3 weeks to live. Since then, we found new medication for him. He's doing a whole lot better, but this is still very much a tribute to the still alive but only just Jim Cable. And I can joke about it because not long ago I was in a meeting with him and we were trying to plan a follow-up session. And he was looking at his calendar and saying, well, I'm not going to be here in 2 months, so we can't delay it too long. He's got that sort of sense of humor. All right, so let's talk about the work that we were talking about. This was a project that was built in northern Iowa. Go through, again, much the same sort of shopping list that previous speakers have talked about. It was a 2-lane county road in the middle of nowhere, right there. Flyover country. Not a lot of traffic on it, 18 miles long, and it was an existing composite system. There were 4 bridges on it. It was an east-west profile in between 2 villages. And the DOT deliberately made a decision that they were going to insist that traffic was maintained on the pavement for the life of the construction process. So, Tom talked a little earlier about, do you rip off the bandage or do you peel it off and suffer? In this case, part of the experiment was to see, well, how bad is it when you peel it off slowly and keep the traffic going? The existing system was in pretty tough shape. The original concrete layer was built in the 30s. It was 18 feet wide. It had a 24-foot widening of about 6 inches of asphalt, and that about is pretty critical to the conversation because in some places it was closer to 1 inch. And it was pretty badly rutted and raveled. And one of the issues is that the underlying concrete layer also was suffering some joint deterioration issues. So there was some wonderful tenting and seasonal stuff that in summer when the snow, the joint was falling apart. So in summer, inside the joint was rubble. And so the snow would melt and it would be a hollow. So the county would come along and fill it up with asphalt. And then in winter, that little hollow part would freeze, and now you had a speed bump every 6 feet. And so they'd grind it off again. And it was beginning to be a bit of a maintenance nightmare. So they eventually decided, okay, we're going to fix this. And they decided they were going to widen it out to 32 feet. They had to maintain the traffic. And then they put all sorts of impositions on safety. So when there was patching and milling activities going on, no more than 2 miles of the road to be closed. If there was mainline paving going on, no more than 3.5 miles to be closed. We had to put in a safety edge between the built and yet to be built systems, and they had to do some adjustments on the cross slope to comply with current details on drainage. And so it's relatively simple to put up a simple diagram like this which says, hey, look, here's the original 18 feet of concrete, here's the widening unit, here's the asphalt on top of it, and this is what we want, go. But in fact, it really did take Dr. Jim Cable living on the site for 5 months to work out the details of where there were intersections, where we were crossing those 4 bridges I talked about, where the asphalt wasn't quite as thick as we thought it was, and all of those things. So it really kept him very occupied for the life of the contract, getting into the guts of the detail. I guess that's one of the caveats, or the sort of heads up, guys. If you're a design engineer, it's relatively simple to put out a drawing like this, but you are going to have to think it through when you get down to detailing a real pavement. One of the other interesting things about this experiment is that the contractor chose to go with stringless paving. And this was deliberate. One, he had the equipment and was actually enjoying it and saving money on it. But two, in order to maintain the traffic, he couldn't afford the space to have 18 inches of roadway chewed up by a piece of string for the traffic to hit. And so, in terms of maintaining access, minimizing disruptions, he went with the stringless profile. For those who don't know it, it's basically you have a bunch of at least 3, preferably 5 total stations. You have the existing and the new profile built into a 3D model on a computer, and the controls on the paving machines are all driven off the information that are coming off the computer model and the total stations that are staggered as you go down the pavement. A little bit more expensive to set up, but a real lifesaver, particularly under conditions like this where it was pretty tight. The DOT originally set up a sort of staging plan of when they were going to be allowed to do various activities along this section. I'll come back to one of the points that Tom made earlier, is that it wasn't a bad plan, but we had a very smart contractor, and he spent a lot of time staring at this and said, I can do better. And so it ended up that we were able to save time on the contract and save quite a lot of effort on the safety edge and other issues just by manipulating the plan a little bit. He still complied with that 2 mile of patching, 3.5 mile of mainline paving, but give it to the guy who's doing it day in and day out and let him think through some of those details. You'll probably come up with a really good plan. So on the patching, one of the ways they handled the traffic were these portable traffic lights. Close off one lane and just let the traffic work it out. Again, the other thing that Tom was talking about was the little old lady staring out of the window who knows more about paving than you do. What we found here was, one, it was absolutely critical to main access for the farmers. Farmers tend to carry rifles in their trucks and like to use them. The other one is that if the farmer couldn't get his vehicle onto his land, he'd just drive over it. And so there were 2 or 3 occasions when you come back in the morning and your nice fresh concrete has got a full-on set of tire tracks through it. A lot of the traffic actually decided they couldn't be bothered with all of this slowing down. They just went a mile north and took the detour, which actually helped because it reduced the traffic that we were trying to deal with on this pavement. What it did mean is that the detour got really badly beaten up, and the county engineer in that county is now really angry, but that's okay. The other approach for the longer sections was a 24-hour pilot car system, and that did help a lot because it did have a strong influence on the safety. Is that when you've got a paving machine, you've got 18 inches and a small cone, you don't want anybody flying down here at 65 with a rifle sticking out of the window. So the pilot car did make a big difference. And it was a safe site. As far as I know, there weren't any significant issues other than the odd crossing. The construction process, also very similar to the stuff that Tim and Tom have talked about. Go in there, fix up what's bad with it originally. Now, the big difference, Tim already alluded to, between an unbonded and a bonded overlay is the condition of the existing system. An unbonded system is assuming that what you've got there is pretty bad, and all you're really trying to do is use it as a foundation. So any repair work that you do on that system is fairly minimal. All you're doing is making it smooth. You don't have to fuss too much about texture and strength and all of that good stuff. Just get it smooth enough that you have a reasonably uniform support system. What they did have to pay a lot of attention to was the drains. One of the delightful things about living in Iowa is that it does get kind of cold. And when water gets underneath your pavement and freezes, it lifts the pavement up. So we've got to pay pretty close attention to making sure that we're not getting water stuck in the saw cuts or getting stuck in blocked edge drains and that sort of thing. So, there was a lot of time and effort on cleaning up the existing edge drains, putting in new ones, sorting out the shoulders. The bridge approaches were also a challenge, and they continue to be so. Then they went in, milled the asphalt, put the overlay down, and put the connections on. Part of their repair work was where there was significant rutting, they went in and just did a partial depth. So they milled out a foot width of the existing asphalt and put a new layer of asphalt back into it. And there was, again, a pretty simple concept, just making it smooth enough to be able to put the concrete down onto a reasonably uniform surface. And as you can see from the photo, it's in pretty tough shape. Where the joints in the original concrete layer were in tough shape, they actually went back in and did a full depth concrete patch in there, and they had quite a few of those to do. This is just a detail of curing, basically cover it up and keep it wet for 24 hours to make sure that that patch does get some sort of hydration behind it. Then they came in and milled the whole system. They were using a 7-foot machine. They were taking off between 1/2 inch to 1.5 inches of material. There was quite a lot of backwards and forwards with the DOT because, again, they were fiddling with trying to get the crossfall to new specifications, but they were also fighting a little bit about the fact that the asphalt that they were lifting up, who owned it? The city or the state or the contractor? And if they milled up a little bit more than they thought or a little bit less, who got the benefit? There was lots of fighting about that, but I managed to stay out of that discussion. The way they did the milling is they controlled it using the stringless on the center line, and then just as they worked outwards, they controlled the machine off the milled surface that they had already started with. So the first run was the critical one to get the slope and the lines correct, and then let it work out after there. So again, here's a fairly typical image of the mill finding its way down the system. And as I said, sometimes they came across spots where the asphalt wasn't quite what they thought it was, and they were starting to expose either lift layers in the asphalt or they were even punching through to the existing concrete layers. So again, I think it was Tom made the point earlier, know what's there, because you are going to have to rethink, make decisions in a hurry as you actually start constructing and meet things that you didn't think were there. Then the tie bars. One of the big issues about putting an overlay on an existing system is that you now have a step along the full length of the highway. So in a way, you're putting a C over an existing hard system. So any horizontal movement towards the center line, or if the vehicles start running on this line, you've now got a stress concentration right there. So one of the ways that they try to get around that in their detailing was to put in these fairly small steel tie bars. What was entertaining, I haven't got the slide with the photograph, but the way that they installed these is they got a little flatbed trailer, and the crew would lie down face first, prone, on the trailer, and shoot the nails into the existing asphalt to get the tie bars down. And this trailer was just towed along by a little gator. There's quite an amusing image of two guys lying down on the job, but actually doing their jobs. And there it is, paving in operation. In this case, nominally unbonded. And the reason it is unbonded is that we're placing on top of asphalt. Now, how much bond is there between asphalt and concrete? Dave and I are going to argue about this in our overlay committee meeting tomorrow at 2 o'clock. From a design point of view, probably none. From a construction point of view, yeah, there may be some bond, but who cares? It all becomes a little philosophical. Here's a typical detail of actually how they were still trying to do the traffic control. So we've got the paving machine tied up against the cones. And in fact, they had a man who was walking down a few feet in front of the paver and sort of move them out a foot when the paving machine came past and move them back again after it had gone past. The pilot car and the vehicles, and again, when they were actually paving, all the vehicles were actually pushed across onto the shoulder. So that's why they had to make sure that they had the shoulder well in place before they did the paving. But this did mean is that they could back up the trucks without driving over those tie bars. So again, very carefully thought through. How much space do we have? How much do we need? How long do the tie bars have to be? How wide's a ready-mix truck? How good is the driver at squeezing his way into that fairly narrow lane? Actually, it entertained me the one time I was standing there. Those guys were getting good. It was a Grand Prix. going backwards, seeing how quickly they could run those vehicles back down. So they were paving pretty quickly, close to 7,000 feet a day. It was starting to get towards the end of summer, so the contractor actually set up a hot water system at his batch plant so that they could make sure that they could still be paving even if it did get reasonably chilly at night and still avoid random cracking issues. And that worked. There were no significant cracking problems on the site. A good contractor and a good crew, and that's indicated by this photograph. One guy with a bull float, everybody else standing and watching. That's the way you want it. Because if you have 7 guys with bull floats, you're probably overworking the surface and you're going to have salt scaling, freeze-thaw issues. So I quite like that one. Again, here's another image of the Stringless. There's one of the GP grand total stations and the antenna poking up from the top of the paving machine talking to the whole system. It wasn't on this project, but it was the same contractor a couple of years before. It was the first time they tried out their Stringless system. It was running very sweetly until they came to their first curve, and the operator of their machine decided he didn't trust this fancy newfangled computer stuff, and he overrode it and got it wrong. So then they had to rip that one out and come back, but this time he trusted it, and it all seemed to work pretty well. This photograph is just of the sawing pattern again, fairly small panels, avoiding the warping issue, and balancing out, trying to keep the joints away from the wheel path. The other issue is that the DOT still insisted, even though that they were complying with their traffic limitations, they still had to insert a safety edge. So the contractor got smart and put in a temporary unit on the back of his paving machine, which became a slip-form safety edge. And so here is that safety edge coming out the back of the paver, being loaded with the bobcat. 24 hours later, or when they were ready to put on the next lift, they would just come and rip that safety edge off. And the way he managed to do that is that he had a geotextile underneath it, acting as a debonding layer. So when he wanted to take it out, all he had to do was to run a blade down there, slide it off, pick it up with a bobcat, and take it away. And that was pretty efficient. So, things that we learned, and this is all written up in a book that's available on our website, a full report on everything that, and this is a document that Jim Cable wrote. Know what's there. It's the things that you didn't think about or the things that you weren't aware of that caused the sleepless nights and the discussions. The details do matter, and that's a large part of our jobs as engineers. We're supposed to be detail-oriented. Building under traffic is possible. We did it. It took 2 months longer than if they'd gone in, shut down, built it, and got the hell out of there. But we did do it. It costs more. It becomes a discussion with the DOT, the cities, the agencies, the whole communication thing that Tom was talking about earlier. It can be done. If you need any more guidance or help, call us. We can help you. I'm going to put one final plug in my last 30 seconds. We've now set up on our website a link to student resources. So all of you faculty or anybody that has access to students, if you go to cptechcenter.org/student resources, a lot of these documents are available for you to use as textbooks or in your early days of practice. With that, beware of those potholes. Thank you.